The diesel engine relies on many critical parts working in harmony, but one of the most essential components for delivering reliable performance is the fuel injection pump. This specific model is built to match the requirements of a Perkins 2.7 liters 3-cylinder diesel engine and is perfectly suited for use in Massey Ferguson 241S tractors and compatible with the 8922A241G engine block. It manages the pressurization and timed injection of diesel fuel, ensuring that combustion is efficient, clean, and powerful. This component operates under high pressure and extreme precision. Without proper fuel delivery, no diesel engine can operate correctly. It doesn't just push fuel through lines, it regulates the exact amount and timing so that each cylinder receives the right dose at the right moment. Even a small variation in delivery pressure or injection timing can cause reduced power, poor throttle response, hard starts, or increased exhaust emissions. This makes selecting, installing, and maintaining the correct pump absolutely crucial. One of the first steps when sourcing a replacement is ensuring that the pump's technical specifications match the original equipment. Flow rate and injection pressure must be consistent with manufacturer tolerances. A mismatch may cause underfueling or overfueling, both of which can damage internal engine components or drastically reduce efficiency. Excess fuel delivery might wash oil from the cylinder walls, while insufficient fuel causes misfiring or knocking. The next consideration is timing. Injection timing controls when fuel enters the combustion chamber in relation to piston movement. Some pumps come with preset timing, while others are designed for adjustable timing. Adjustable versions offer more flexibility but require accurate calibration tools and knowledge of the engine's timing marks. When timed correctly, the combustion cycle becomes more efficient, increasing fuel economy and decreasing smoke output. It's also important to evaluate the build quality. High-grade pumps use hardened internal parts like steel plungers, copper or brass fittings, durable springs, and high-tolerance seals that can withstand long-term exposure to pressure and heat without degrading. Low-quality alternatives may work for a while but often break down early due to wear, internal leaks, or pressure fluctuations that throw off injection timing. Compatibility with your existing engine hardware is also a major factor. The bolt pattern, flange design, dowel pin alignment, and shaft dimensions must all match precisely. A poor fit may lead to uneven torque on the housing, improper sealing, or vibration that could reduce the pump's lifespan. Some models may include replacement gaskets or seals, but it's always wise to inspect existing parts and replace as needed during the installation process. The condition of your fuel lines and fittings also comes into play. Aging hoses, rusted clamps, or clogged filters can affect performance even with a brand new pump. Ensuring these components are clean, leak-free, and correctly routed will prevent air intrusion and maintain constant pressure throughout the fuel system. Installing the pump begins with isolating the fuel system. Always disconnect the battery and depressurize the lines to prevent fuel spray. Clean the surrounding area to minimize contamination. Once the old pump is removed, inspect the mounting surface. Scratches, corrosion, or gasket residue can cause sealing issues. Clean it thoroughly and check that dowel pins are intact. Fit the new pump carefully without forcing it into place. Bolts should be torqued in a crisscross pattern to ensure even pressure. Use manufacturer torque specifications to avoid cracking the housing or warping the flange. Once mounted, reconnect all fuel lines, checking each one for secure connection and potential leaks. Next is bleeding the air out of the system. Most engines won't start unless air is completely purged. Depending on your setup, you can either manually pump a priming lever or crank the engine while keeping the injector line slightly open. Watch for a steady stream of fuel exiting the return line, then tighten everything up before attempting a full start. When the engine starts, let it idle for a few minutes while monitoring the exhaust for unusual smoke. Blue smoke indicates oil burn, white means unburned fuel or air, and black suggests too much fuel. Listen for unusual noises and ensure the idle is smooth. After a few minutes, increase throttle slightly to test response. If everything feels stable, take it through a short load test. If the replacement pump is functioning properly, you should see improved cold start behavior, reduced smoke, more consistent throttle control, and even engine tone. If symptoms persist, double-check your timing, fuel lines, and connections.